Hello, this is a special case of double inequalities. How is it special? Well, we have double inequalities as before, but we have x all over the place, here, here and there. Do you understand? In both the cases we have something like this. How to solve this kind of double inequality? Why is it double? Double because two inequalities. Inequality greater than or less than sign. Correct. Method followed is exactly the same. Fortunately for us, it has an easy solution. We'll look for difficult solution in part 3. Let me call for the moment this double inequality as part 2. Okay. Then we'll get to a difficult case. Okay. Now here, what we will do is we'll get rid of x from the outside. So what we can do? We can take away x. Correct? If you do take away x, what are you left with? So first strategy is take away x, right, from every place. This is our strategy, correct? So if I take away x, that means I am left with minus 6 here, less than 2x minus x is less than x minus x is 0, and we get our answer. That is, x is greater than minus 6 and less than 0. Do you get? So simple it is, right? I couldn't have made a simpler question for myself. Now here, this answer can be represented on a number line, and on a number line, I can say if this is my number line and here is my 0, in that case, and let's say here is my minus 6, then these two numbers are not included, so I will write here 0 and I'll connect them like this. Okay, so that is my solution on a number line, correct? Fine. If I have to write this in interval notation, then I can write like this. The solution is from minus 6 to 0, both are not included. That is my value of x, which will solve this inequality. Perfect. Now let me do the next one. Here again, I'm doing the same strategy. What is it? These are x's. I'm eliminating x's from this and this. So I do minus x from here, minus x from here, and minus x from here. Once I do it, I'm left with minus 10 is less than 2x minus x is x, plus 4 is less than x minus x is 0. You're left with 12. Correct. Now because I have 4 here, as we did in double inequality first part, we will take away 4 from each side, right? So if I do that, that means what am I doing next step is take away 4. Is it okay? Take away 4. And if I do that, I am left with minus 10 minus 4 is minus 14 is less than x is less than 12 take away 4 is 8. Is that okay? And then what is my solution on a number line? On my number line, my solution is, let's say this number is 8 for me, and this number is minus 14. Let me write this as minus 14 here and plus 8 here. On the number line, I will show like a hole here and a hole here and join them. So x is between minus 14 and 8, not including 14 minus and 8. Correct? How will I write this in interval notation? Interval notation, I'll write like this. Minus 14, that means this is not included, and 8, all real numbers between them, correct? And this is which notation? Inequality, correct? Set form, can you write it in set form? Yes, I think you can. In set form, we will say x belongs to real numbers where x is greater than minus 14 and less than 8. So that's my solution in the set form. Okay, I hope you understand this kind of inequality. If you find x in too many places all around, then you can get rid of x. In the next section, we will solve problems where x is not there everywhere but in some places. For example, if I change my equation, that is, if I make this as x minus 10 is less than 2x plus 4 is less than, let's say, just the number 12, and I don't include this x. Then imagine If I take away x, I can get rid of this x, but no, here it doesn't make sense. X is greater than something, and which is greater than something. I may or may not get an answer, correct? So there could be difficulties at times in doing such kind of problems. We will take up those problems in the next section, okay? By the way, understand double inequality solutions in part 1 and part 2 and get ready for the next section. Okay, thank you.